Two and a Half Admins, episode 43. I'm Joe.
I'm Jim.
And I'm Alan.
And here we are again. And before we get started, you want to plug your History of ZFS Part 2.
Yeah, it's just an article on our website talking about the transformation of ZFS over time from the original work at Sun to it becoming open source. It was in Part 1, and then now we're talking about Part 2 as Oracle ruined everything, and then Illumos came up, and then OpenZFS happened, and now everything's happy.
Right, well, link in the show notes as usual. Let's start with something that you found, Alan. And this is from the University of Cambridge in the UK. Ultra-high density hard drives made with graphene store 10 times more data.
Yeah, so currently hard drives use what is called carbon-based overcoats. And it's kind of the layer of stuff on the platter that protects the platter from mechanical damage and corrosion, like rusting. And back in the 90s, that was 12.5 nanometers thick. And today it's about 3 nanometers thick. And that gives you a density of about 1 terabyte per square inch. But by replacing it with between 1 and 4 layers of this graphene stuff, they found that the friction was even better and the wear, corrosion, and thermal stability was even better. And importantly, it's compatible with the existing lubricants. So with this unbeatable thinness, that means that they could potentially get hard drives that are up to 10 times as dense and 2.5 times slower corrosion than they have now. But the other important thing is because they're more thermally stable than the old ones, it means technologies like HAMR, heat-assisted magnetic recording, where you basically use a laser to heat up the part of the platter before you write to it to make the bits easier to flip. And then when it cools, they're harder to flip so that it doesn't accidentally flip, means that they could get to 10 terabytes per square inch. So up to 10 times the density on hard drives.
I can't wait for what that does for resilver times.
Well, it should have a somewhat of an increase in the raw throughput, but you're probably not going to, it's not going to have any impact on the IOPS per terabyte. Or rather, it's going to have a very large negative impact on the IOPS per terabytes because you're going to have the same number of IOPS and 10 times as many terabytes.
That does illustrate the problem here, that really hard drives are already at a point where they've got almost too much data and so little throughput.
Well, it depends what you're doing with the data.
Yeah.
The throughput has been going up and it is running into limits, but the throughput's not the problem. It's the IOPS. Basically, if you're not reading a file that's written out linearly and you're having to seek around the drive, then you don't get the 200 megabytes a second. You get like 8. And that's obviously not good enough. Now, we talked a little bit about in a number of weeks ago, the Seagate dual actuator drives, which do basically give you double the IOPS, but that's going from like 150 to 200 to up to maybe 400 IOPS, whereas, your NVMe disk is like, yes, I have 250,000 IOPS per terabyte.
This basically just further extends the division between the use case for, Rust and solid state.
Yeah.
In a way, this would have been really bad news if Rust was still the only real random access storage technology we had, because it would just, have increased that progression without any choices, for a different technology that better suited high IOPS use cases. But we have that better technology for those high IOPS use cases. They're called solid state drives. And, we still have the issue right now that you choose between bulk cheap storage and high IOPS, and you use solid state for one and you use Rust for the other. This just further increases Rust's advantage over solid state, the one advantage that it does have, which is the storage density.
Yeah, by 10xing the storage density, it just means that all the stuff that you maybe need to be able to stream but aren't going to worry about the random access speed of, like archive type stuff, you'll be able to fit that much more. For your backups, where you're hoping you write them and never have to read them, but if you do, it does need to work. It just means you can back up 10 times as much stuff in the same amount of rack space.
The thing here is Rust is actually already dead for most consumer use cases. Most consumers don't even touch a Rust disk anymore. Rust is already for bulk storage from prosumer or better level technical competence. So, for those folks, it's just a win. I mean, will a few particularly not yet clued in shade tree sysadmins get themselves into trouble with more data than they've got the redundancy for? Sure, they will, but they were already doing that. And I don't think this is really going to make it that much worse, honestly. People still don't understand the difference between IOPS bottlenecks and throughput bottlenecks, and I don't think they were going to suddenly start universally understanding it before, and this isn't really going to make that understanding any worse.
So there's no time frame in this press release. What do you think we're looking at here? Are we talking like 5 to 10 years, or are we talking sooner than that?
It's a bet, but my bet is 2. You're probably looking about 2 to 3 years to start seeing this showing up. It probably will not show up in consumer accessible products first. If it follows the same pattern as SMR did and dual actuators with Seagate now, you're basically looking at about a 2-year lead time, probably about a year to 18 months of that. Again, this is wild speculation, but usually the pattern you see is a few months after an announcement like this, they start selectively sending disks with this technology out to their larger enterprise partners, their most clued in enterprise partners to find uses for it. They'll start widening how many enterprise customers get access to these things. And then after a couple of years of that kind of testing with partners, that's when you start seeing things hit the open enterprise market, where in theory a consumer could buy it, but they still probably couldn't do much with it because it'll probably be like, SAS rather than SATA and, all those good differentiators, but you can at least buy it.
Yeah, I guess one of the things we don't know at this point is, when Seagate announced their roadmap earlier this year that had 40 to 50 terabyte hard drives in the next couple of years, if that was with or without this.
I'm going to go with without. Just looking at the curve of how large, drives have gotten over time. So 40 terabytes, you're only talking about roughly doubling what we've already got out there, widely available 18, 20 terabyte drives. So I don't think you needed magical graphene technology for that, particularly when, these folks are saying they're not talking about doubling the density. They're talking about 10 times the density, an order of magnitude. Mm-hmm. So I think you're probably looking at, 150, 200, maybe even larger, terabyte drives when this is actually available in production. Assuming their claims are accurate, which again, we're speculating about all kinds of vapor at this point.
The most important question, though, that we haven't answered, what is this going to do to the price of Chia?
Ugh.
Well, hopefully that'll have died off before these drives ship.
With any luck, yeah.
That will not have happened.
Yeah.
These damn coins never die off. It's just, it's like the XKCD about standards. You just add more of them.
Right. I just mean people won't be buying up drives and causing shortages, hopefully by then.
Hopefully.
Other interesting stat they just happen to have here, for in the year 2020, they shipped about 1 billion terabytes of fresh hard drives. They say HDD. I'm assuming they actually mean non-flash storage and not a mix of the two. But if that's right, then it'll be very scary to see what that number is going to look like in 2023 or 2024 when this stuff starts shipping.
A more serious answer to your question, Joe, about Chia, we're not really seeing runs on Rust disks for Chia. We're seeing runs on the solid state disk that you use while you're still plotting out the initial map before you actually start farming the Chia. So this should not really have any impact one way or the other.
I don't know how much of it is just speculation or whatever, but Seagate has raised their stock market guidance this morning, I think, based on a large uptick in sales.
Yeah, and you try going to Amazon and buying any sort of even USB cheapo hard drives, they've all gone up in price.
Yeah, well, some of that is just gouging or the Amazon algorithm.
Well, and the USB hard drives, those are never priced like accurately. It's all like, great big sales and then stopping the sale and seeing if people still buy it at the higher price, loss leader stuff. I always advise people, and this is not a popular opinion like in, our data hoarder, but I'm always like, stop buying these USB drives and shucking them for your big RAID arrays, because these are literally the worst garbage crap. You don't know what you're getting. Sometimes it's, QA failed enterprise stuff that like works well enough to be consumer, but was not good enough to, put into the enterprise line. Sometimes it's consumer stuff. You don't really know what's going to be under the hood. And the failure rates on those things are way higher than I just bought a hard drive at the price I should buy a hard drive, and I didn't do this weird around my back to get the USB priced low to sell to grandma, but I shucked it and did the thing because I'm smart.
Well, and they sometimes have like weird firmwares and all kinds of things. It's like, no, don't buy that USB garbage.
Yeah, some of them are unshuckable too, because I ran into a few. I didn't actually run into it trying to shuck them. I ran into people who had failed USB externals, and I'm like, oh, well, no big. That's usually the power supply. So I'll just crack the case and, plug it into a real machine and pull the data off. I used to do that all the time because it usually was the power supply that failed, not the actual internal drive. But a lot of models of USB external now do not have a SATA interface. The USB is soldered directly to the board on the drive.
Yeah, they replaced the normal drive controller with a USB one, and so it doesn't even speak the protocols.
And let me tell you what, you're not going to be able to return that drive after you break open the case permanently to discover there's no SATA interface.
Okay, this episode is sponsored by Linode. Go to linode.com/2.5 to get started with $100 free credit and 60 days to use it. Linode offers cloud computing solutions in data centers all over the world. Whether it's scalable VMs with a choice of major distros or one-click apps and stacks, dedicated CPU and high RAM instances, block and object storage, or cloud firewalls and DDoS protection, Linode has everything you need for your personal projects right up to managed enterprise infrastructure. I recently moved my website over to Linode and it was really straightforward. And when I needed a Mumble server for our Late Night Linux community meetups, spinning up a new VM for that was an absolute breeze. Everything's been running flawlessly since I set it up, and I love the peace of mind I get from the automatic backups. So go to linode.com/2.5, get your $100 credit, and check out Linode's great cloud hosting services and first-class always available support. That's linode.com/2.5. Let's talk about Amazon Sidewalk. So if you've got one of several different connected Amazon devices, in the US at least for now, then you have been opted in by default to this new scheme of theirs where they will share your internet connection with other Amazon customers using their own proprietary encryption. What could possibly go wrong with this?
Oh, I'm sure it'll be perfectly fine.
You remember when Comcast started doing this automatically with their Wi-Fi modems or whatever, and people were upset? With the Amazon one, does it tunnel back to Amazon before it goes out to the internet, or do people go out with your IP address?
We have to correct a misunderstanding here. Sidewalk is not supposed to let you just connect to any random person's internet and, go to reddit.com/rfilth like Joe. It's only for IoT type use cases, in particular, an Amazon branded, Find My type service, kind of like Apple's Find My iPhone, where if you're using AirTags or if you lose your iPhone, you're not just limited to the direct, connectivity of that device. Any other Apple device in the vicinity of that one will detect it and will relay to the internet where that thing is. So that kind of activity is what Sidewalk is for. It's basically... It's not really giving it to other people. It's more Amazon is using that for Amazon purposes, including other people's devices that are within range. It's also bandwidth limited. The maximum bandwidth of a Sidewalk device to the Sidewalk server is 80 kilobits, and the monthly bandwidth per account is capped at 500 megabytes. Now, that last part can be a problem for some people because there are some ISPs out there that have just absolutely horrible monthly bandwidth caps, like a gig. So you could literally spend half of your already criminally tiny bandwidth cap on, Sidewalk. So if you are one of those folks with a metered connection, you really want to pay close attention to that and make sure to disable it.
Okay, so it's quite a bit different than the Comcast one, which was literally just we're turning your Wi-Fi access point into broadcasting a second SSID that's just open to any other Comcast subscriber.
Yeah.
Other questions from the Sidewalk thing about, using it to cyberstalk your girlfriend who you abuse and things like that.
Yeah. I mean, to be fair, that's not really a problem with Sidewalk itself. It's a problem with, any tracking service. I mean, yeah, it's tracking tools. They can be used for Lovent.
Lovent. That's an interesting way to put it. I like that.
Are you not familiar with that?
I'd never heard that term before.
You got like SIGINT, Signals Intelligence. You got HUMINT, Human Intelligence. You also got LOVENT, which is when your security people start stalking their ex or, the girl that you just thought was cute they saw at the bar and, all that kind of thing.
Yep.
Let's do some free consulting then. But before that, just a quick thank you to everyone who supports us with PayPal and Patreon. We really do appreciate that. You can go to 2.5admins.com/support if you want to learn more about that. And remember, for $5 or more per month on Patreon, you can get an advert-free RSS feed, so check it out. And if you want to send in your questions or feedback, show@2.5admins.com is the best way. So Joe wrote, not me, I ran into an interesting issue. I had an SSD with Ubuntu on it. All smart tests from GNOME disks show it working fine, but FSCK and GNOME disks show errors on the file system. Fixing fails. The GNOME disk utility throws udisk error quark 0. Even deleting the partitions and trying to reformat fails. I've tried with a bunch of Linux distros and even Disk Manager in Windows. The disk is 100% stuck in a read-only state. I'm guessing the SSD is dead, but could there be anything more to check? The data is still readable, but otherwise unusable.
That's typical of what an SSD will do when it runs out of write endurance. Basically, when it's worn out, the flash cells and the wear leveling has done everything it can do. That will often show up in Smart as one of the counters showing that the capacity is either 0% left or 100% used, but that won't necessarily cause the overall Smart status of the disk to go to something that will stand out. So it's hard to say without seeing the actual error messages or what the actual output of Smart CTL.
In general, I just like to add that Smart isn't.
Right.
The number of times that Smart has reported a problem with a disk that was failing is way less than 50% in my personal experience. Usually disks fail and Smart says, yep, it's fine.
Yeah, there are some indicators in the Smart that if you watch them and see a trend over time, will tell you that the disk is probably not okay, but it almost never is definitively, yeah, that disk is totally hosed. It does a very bad job of its one job, which is predicting when the disk is going to fail and giving you time before. Luckily, if it is... in many cases, SSDs will fail in a way where you can at least still read the data off to back it up, but not always, so don't depend on that.
Yeah. And this does sound kind of like write exhaustion, but write exhaustion doesn't usually just show up out of the blue one day.
Yeah.
Normally what you'll see is the SSD just becoming glacially slow and getting slower and slower and slower, and you'll be unwilling to deal with the thing long before it becomes actually completely write endurance exhausted. If I had to guess, I would guess it probably more of a hardware failure or a firmware bug in this case.
Yeah, possibly the power loss you mentioned scrambled the flash translation layer's internal storage of what's where. And it's just like, I'll let you read what you can, but if I do any writing, I risk making it worse.
You didn't mention the model of the solid-state drive, but frequently you can reflash the firmware on solid-state drives with updated versions, and that might be worth trying if you particularly want to get this SSD working again, just as a usable disk. Although I will note that if it wasn't particularly expensive and isn't particularly new, I wouldn't.
Yeah, I wouldn't spend the effort on a disk that maybe isn't even any good.
Yeah, it was one thing when, like an Intel X25M at, 80 gigs, you might pay $350 for, 12 years ago?
I have some of the first ones that were only 32 gigs.
The initial models were either 40 gigs or 80 gigs.
It wasn't 40 or 80. It was like 32 or 36 or something.
Some of the later ones came in binary increments, but the initial ones were either 40 gig or 80 gig. I sold a lot of those things. When people kept laughing at them, who would pay $350 for such a tiny drive when I can pay $80 and get a 1 terabyte hard drive? I bought one just to see because I didn't know, and I put it in an ancient used laptop and was like, holy crap. And I took it around to all my clients and showed them this ancient piece of crap laptop, booting just near instantly and everything just flying onto the screen. And all of a sudden, everybody's like, heck yes, we want to pay you a large markup for what was already a very expensive drive to retrofit all of our systems.
I put it as an extra drive and put my MySQL database on it, and it was very fast, and I was happy.
Crucial disks had really bad problems with the firmware, and frequently they would lock up in very similar ways to what you're describing, and you could fix it by manually updating the firmware.
But yeah, like Jim said, if it's already dodgy and it's not new and expensive, a new SSD is probably going to make you happier and make it easier to sleep at night. So luckily you can read it so you can copy your files off.
Yeah.
Okay, this episode is sponsored by CBT Nuggets, training for IT professionals or anyone looking to build IT skills. Go to cbtnuggets.com/25admins and sign up for a 7-day free trial. The on-demand virtual labs mean you can build practical experience with the commands, config, scripts, and everything you need to get the most out of each course. Another standout feature is the accountability coaching service, available to all learners with a subscription, which gives you access to a real person who will help you craft a personalized learning plan and set goals, and will check in with you to keep you accountable. So start your free 7-day trial today at cbtnuggets.com/25admins. It includes unlimited access to all course materials, including virtual labs. That's cbtnuggets.com/25admins. Okay, Scott says, I have a dilemma. I'm migrating to a new server architecture based on ZFS with Jim's Sanoid and Syncoid for remote backups to ZFS.rent. Both push and pull backups seem vulnerable. Pull might compromise the server from the backup hosting service, while push might make it so that a ransomware compromise could also compromise the backups. Is there some third option I haven't thought of yet? If not, do you recommend push or pull? And this does come up quite a lot, this push or pull debate.
The issue here in push versus pull is you always want it to go in the direction where the more trustworthy server has more control, more privileges. It's a trust issue. And if you're doing a push backup, that means that you don't trust the backup service. If you're doing a pull backup, that means that you don't really trust your production, the source of the backup data. You almost always want to do a pull because when you've got a dedicated backup server or dedicated backup service, there's just a lot less attack surface on that thing. Your production has got the most horrible security vulnerability possible on it, to wit, a human being. That's where the vast majority of your security issues come from, is the hairless monkey sitting in front of the thing and doing God knows what with it. Now, there is more of a trust issue when you're not managing the remote backup service. I understand hesitancy to, trust an actual third-party multi-tenant service like ZFS.rent or like rsync.net. With that said, the odds are still pretty good that they're going to be less likely to get compromised as frequently as your own production. Because again, there's just a lot less direct, ad hoc, and arbitrary human interaction.
So like we told the person last week who was doing the cross backups with their friend, you want to use ZFS allow to delegate permissions and have the minimum possible set of permissions. So you want to have the shell on ZFS.rent pulling the backup from your machine and doing that with an unprivileged user. So you will create a special user just for the backup service, and the backup service will connect in as that user, and they'll have only the ability to send the datasets you say to the backup service. They won't have the ability to delete any of your datasets or to even delete snapshots. You can do that out of band. And that way, if that is the thing that get compromised and they can connect into your machine, all they can do is send a backup of your data, which, if you're using ZFS raw replication with the encrypted data, means all they can do is blast themselves in the face with gibberish. And it means that they won't be able to do anything bad to your machine.
Can you do the ZFS delegation so fine-grained that you're only allowing the raw send and you won't allow a regular send?
I don't think it actually has that option, but it should.
It should. Get to work, Alan. Start patching that. Credit me for the idea.
Where's my ZFS to-do list? It's very long.
Is it about as long as our ZFS questions list?
No, it's longer than that.
Okay, Jeremy asks, what of the two options below do you think is the most secure and why? Okay, the first one is key-only SSH on a non-standard port with access only allowed from a whitelist set of IPs. Is key-only fine, or would you recommend I configure a YubiKey 2FA for SSH? And the other option is WireGuard/Nebula VPN. What are your thoughts on having both options configured on my server? If WireGuard gets wedged somehow, I have a fallback. I currently only have the first option set up, but I'm considering the second option as well. I also have PSAD to black hole port scanners, and I'm considering moving to Suricata. Do you have any input or recommendations here?
I have input on what constitutes a question.
Yeah. So it depends what you're trying to do. Like if you want to remote administer the server, even if you have WireGuard, you still need something to let you log into the server, like SSH. Now, you could configure the SSH to only be listening on the VPN IP or something, but I think key-only SSH is fine. I think doing the whitelist of IPs might be making your life more difficult.
Yes.
And lead to situations where you can't access things, and that's probably not helpful. So some form of 2FA may be what you're looking for, and it comes down to deciding what you want, I guess. In the end, WireGuard's authentication with a key is basically the exact same technology underneath as an SSH key. So they're pretty equivalent.
Yeah. I will say the WireGuard authentication is faster than SSH key-based authentication. The only reason I know this is because I've spent so many years testing really crappy Wi-Fi, and I discovered pretty rapidly that if you've got password-based SSH, that will work over even the garbagiest of Wi-Fi that's sufficient to load a web page. But there are all kinds of situations where the Wi-Fi is good enough that you can do casual internet browsing, but key-based SSH will fail every time. It'll time out, in like 90 seconds.
Just one too many back and forths?
I'm not real sure. I actually asked on Stack Exchange. I never got a convincing explanation. I don't know if it's a millisecond timeout issue having to do with the authentication portion, or if there's parts of it. I don't know. I just don't know.
I've never run into that, even using crappy conference Wi-Fi on a FreeBSD laptop where the Wi-Fi barely worked at the time, and I still didn't have any trouble logging in with a key.
It has been the bane of my existence across more devices, both compute and Wi-Fi, than I can count, man. If it was only one thing or the other, well, obviously the SSH is the more secure because it's not just SSH. It's SSH on a non-standard port with a whitelist of IPs and possibly two-factor versus just WireGuard. But as Alan pointed out a minute ago, it's not going to be just WireGuard. It's going to be WireGuard followed by key-based SSH. And I think the big thing to be gained there is the WireGuard may help a little bit with your, I don't want to be unfair, but the paranoia leading to only the whitelisted set of IPs. Now, if you truly only have to access the machine from a couple of places that have static public IP addresses, then that might be perfectly fine. And never mind me, that's great then. Absolutely do a whitelist. But if you have people who need to access the machine, from the road or from home or from someplace that, only has dynamic public IP addresses, WireGuard or Nebula will absolutely solve that problem for you.
What about this idea of moving it off 22? Isn't that just security through obscurity?
It is. You'll find people who argue that, you absolutely have to do that because otherwise the brute force attempts, just fill up your logs and eat up all your bandwidth and yada, yada, yada. But that leads us back into, what Alan and I are always preaching, which is you just do rate limiting. If you properly rate limit your SSH login attempts, then you don't have brute force problems because the people who try just get tarp hitted and everything's fine.
Nick wrote to us, I'd love to hear about how you plan and prototype new systems and tests that must be passed before deployment/production.
I guess it really depends what the system does. For storage, it's mostly give it 2 or 3 days with some I/O to make sure you've gotten through the rough part of the bathtub on the hard drive. Basically, if a hard drive is going to fail, it's usually within the first 48 hours of actually being under load. And so you make sure you deal with that and that, you made sure that all the temperatures are in the ranges you expect and things like that for physically building the machine. For the software, I generally don't have a lot of fear there because I'm usually making systems that are very disposable. And so either it works or it doesn't. And if it doesn't, you just delete it and start over again.
Yeah, it's the same for me because basically everything I do these days is hyperconverged infrastructure. So all the real work happens inside a VM. The host is a pretty generic box, really. It just has to be functioning. So, if it's starting the VMs, then it's pretty much doing its job. Depending on the scale of the deployment, there might or might not be, an extended burn-in period with, specifically a bunch of activity on the disks to make sure those don't fail, or a bunch of activity on the CPU to make sure you generate heat inside the chassis and everything cools properly and yada, yada, yada. But generally, even in small businesses, I'm redundant on everything, so it's honestly kind of not worth it. If the box stood up and it let me create the pool and it let me replicate all the data in to begin with, it's probably going to be fine. And if it's not, then I can fire everything up on the hot spare in 5 minutes anyway. So I'm not usually that concerned about it.
I think the only bit of my infrastructure that requires a bit of manual setup is a mail server just because of how gnarly mail is. But outside of that, almost everything is pretty straightforward. It's like install a couple of packages and drop in a config file and it runs. There's not much else to do.
Well, the mail server is gnarly, but again, that's not something that's generally going to be, that doesn't have anything to do with a new system for me. That's a new VM, that's a whole different question. And there's not any one answer for that because God only knows what it's doing,
But yeah, for hardware, there's not much to it. For the video streaming stuff, we get new hardware on a fairly regular basis, and it's literally just via the IPMI thing, boot the our installer image over the crazy KVM over the internet thingy and splat down our OS, which literally just, it asks a couple of questions. Basically, what's the system's host name and IP address? And which disks should I format? And then it literally just runs the equivalent of curl pipe ZFS receive to install the system. And it grabs an already built golden image of what a new server should look like. And then once that's in place, it echoes a couple of lines in rc.conf to set the host name and the IP address. And then you reboot and you have a working video streaming server.
Right, well, we'd better get out of here then. Remember, show@2.5admins.com if you want to send in your questions or feedback. You can find me on Twitter @Joe Ressington.
I'm @JRSSNet.
And I'm @Alan Jude. And if you're Jim, that's ALLANJUDE.
We'll see you next week.